So today we will learn another important concept in network analysis called as the nodal analysis. तो पहले हम थोड़ा theory पढ़ेंगे इस पे, then हम एक numerical solve करेंगे. So talking about nodal analysis. So there are various ways to solve a particular circuit diagram to find out the current voltages. Few of them we have learned, such as mesh analysis. The next one is the nodal analysis. So nodal analysis is dependent upon KCL. What is KCL? Kirchhoff's current law. So what does Kirchhoff current law say? The algebraic sum of current entering the node is equal to the algebraic sum of current leaving the node. So for example, I have this node A, okay, and I have various branches to it. And this is I1, I2, I3, I4, I5, and I6. So if you see, what does KCL say? KCL is Kirchhoff voltage law, in which the algebraic sum of current entering the node is equal to algebraic sum of current leaving the node. So what are the currents entering the node? I1, I2, I3, I4. And what are the currents leaving the node? I5 and I6. So I1, so the algebraic sum of current entering the node. So entering the node is I1 plus I2 plus I3 plus I3 plus I2 plus I4 is equal to algebraic sum of current leaving the node. So what are leaving the node? I5 and I6. I5 plus I6. So this is the KCL equation. So nodal analysis depends upon KCL, which is Kirchhoff's current law, and it says the algebraic sum of current entering the node is equal to algebraic sum of current leaving the node. So that's it. So now we'll try to solve one question by nodal analysis. Okay, so please go through the question once and make a note of it. The question says, find the voltage across the 5 ohm resistor. This So find the voltage across the 5 ohm resistor using nodal analysis. So there are various ways to find out the voltage across 5 ohm resistor. You can do mesh analysis, KCL, KVL, you can do superposition theorem, you can do so many other techniques such as source transformation. But here we will have to solve it via nodal analysis. So how do we do it? Let's try to understand. So let's try to do the solution part of it. Okay. So the first step will be apply KCL. As I told you, the nodal analysis depends upon only KCL. So you have node. So this is a node, right? So this is a node A, for example. So imagine this is a node A. So how do you identify a particular node? A node will have more than two branches. So if you see here, there's only one branch and there's another branch. So here there are three branches, right? One, two, three. But again, this and this are at the same potential, right? So I can just club it here, A. And here we have two branches, so that is not a node. So if you want to identify a node in terms of nodal analysis, you should have three branches. So here we have only two branch, one, two. Here we have three branch, one, two, three. But since this and this are at same potential by a short circuit, so I can consider this node to be same as this node. And here you have 1 and 2. So we have only one node in this particular question. So apply KCL at node A and assume currents to be outgoing. So apply KCL at node A and assume currents to be outgoing. So what we are going to do in this case is that we are going to apply KCL over here, and we are going to assume that all the currents are going to be outgoing. So if there is a current which is incoming, we are going to take it as the negative form of it. Like for example, 2 amperes current. So 2 amperes current is incoming to the node, right? which is opposite to my outgoing assumption. Hence, I'm considering -2 plus the current flowing through 5 ohm resistor can be considered as VA upon 5, right? So the voltage across this resistor upon 5 is the current plus, let me write down, VA plus 30 into I1 upon 10. So you have VA, then you have plus 30 I1 upon 10, because this is the voltage here. This is also a voltage, a dependent voltage source upon 10. So how do you get this equation? I'll show you. So if I just have to apply KVL here, it's going to be VA minus of 30 into I, let's see, and plus of 30 into I1 is equal to 0. So if I apply voltage KVL over here, so VA plus 30 upon I1 upon 30 is equal to I. So the current flowing in this branch is equal to VA plus 30 into I1 upon 30 is equal to I. So what is nodal analysis? Nodal analysis means that this is the node A, and at this node A, you need to find out the various currents which are happening. So apply KCL at node A and assume the currents to be outgoing. So since we assume current to be outgoing, if there is an incoming current, is going to be -2. Current in this branch is VA upon 5 plus what is the current in this branch, that we can find out by applying KVL in this branch, and VA plus 30 I1 upon 30. And what is the current in this branch? Straight away plus I1, right? The entire current in this branch is given as I1 is equal to 0. Now, what is I1 equal to? I1 is nothing else that apply KVL here, right? So if I apply KVL over here, it is VA minus of 20 into I1 minus of 10 into I1 minus 50 equals 0. Therefore, I1 is equal to VA minus 50 upon 30, right? So your I1 is equal to VA minus 50 upon 30. So you have the voltage at node A, VA minus 20 into I1 minus of 10 into I1 minus 50 is equal to 0. Therefore, I1 is equal to VA minus 50 upon 30. This is the value of I1. So what is I1? VA minus 50 by 30. So this is equation 1. This is equation 2. If you substitute I1 over here, the entire equation will be in forms of VA. So what do I do? Minus of, so substituting 2 in 1. I'm sorry. Substituting 2 in 1. I'm sorry for this. Substituting 2 in 1. So we're substituting 2 in 1. So what's going to happen? If you substitute 2 in 1, finally you will get VA as 20 volts. And this VA is nothing else than the voltage across 5 ohm resistance. So this is about nodal analysis. Okay, so please make a note. Thank you.